Welcome. Thank you for taking the time to hear some of our thoughts on current and future storage trends. I'm Russ McElroy. I'm Senior Manager for eBay Inc. Farid Yavari is one of my architects. Together, we're responsible for the roadmap, the vision for the strategy, the architecture, as well as the day-to-day operations for eBay Inc., including PayPal, eBay marketplaces, and associated adjacencies. So, when we think about the vision and trying to define where we want to be in 3 years, we try to think about 3 years out, where we want to try to meet the trends and where we want to take our data center. We get some of our inspiration from looking at what our platform, not only from what our platform is demanding. We also look at the market, what's going on. We talked a lot with industry, and we probably have about 100 NDAs, and while I can't talk specifically about anything, we do get a sense of general trends that are going on, what kind of technologies have the best chance of coming to market. But an interesting thing is you can also look at other systems outside of the industry for inspiration, such as when you look at very dense storage systems in nature. For instance, when you look at how much storage capacity is within the human body as far as storing within our DNA, it's a very dense system, stores a lot of data. You have a DNA matrix or a double helix, which stores base pairs. Each base pair represents 2 bits. You need 4 of those for a byte. All in all, if you look at all the chromosomes in a cell, there are 6 billion base pairs. And given that the average human body has about 100 trillion cells, that's 150 zettabytes in a single human body. So we don't really have the systems today to really manipulate and the tools to really manipulate at that level. But we are able to work at the nanoscale. And there are some interesting technologies. And when you look at things like technologies like carbon nanotubes, they are very similar to the structure of DNA. With a chromosome, the width is in the angstroms, but the length is a macro scale. It's measured in meters if you stretched it out in a single cell. It's very similar to carbon nanotubes, very narrow, but also measured in macro when you expand it. It can be at a macro scale in length. So these technologies, that's a very similar man-made technology that we can potentially leverage in the future to build very dense storage systems that are reliable. So when talking about the eBay platform and where it's taking us and what we need to build for our customers, we do have an OLA-based model or an operational level agreement. So when our customers come to us, it's about requirements around IOPS, latency, capacity, as well as cost. So when we have a model like that, we need to have a lot of flexibility in all those different storage tiers that we offer. For us, we do depend on OpenStack. There was an announcement in March that PayPal is now 100% OpenStack. eBay is also getting there as well. But when we need to have the flexibility, because a lot of times these applications are not really coming in at the right tier, or life cycle of the data changes. So we need to be able to move very nimbly without having any impact to the applications above between the different tiers. Very often data is very active when it's young, and then that same data will, as it gets older, it gets colder very quickly. So looking at the biggest tenant in the environment, the eBay marketplace, 255 billion in gross merchandise volume on the site. It has 152 million users. It is a platform that is a kind of a neutral arbiter in the market. We're not competing with the sellers. One big area that's been growing for us is the mobile side. So while the site may be growing at about 10% a year, the mobile side is growing 60 to 70%, and this has had some implications in storage for sure. Now, PayPal is a payment platform. It allows buyers and sellers to do payments easily, safely. 193 countries it operates in 25 different currencies. Now, if you look at the market, as far as the top 1 million sites, this is probably similar tech that does a comparison of payment technologies. Whether it's the top 10K sites, the top 100K sites, and the top 1 million active sites, PayPal is the most commonly used payment technology out there. And then the other major entity is GSI or eBay Enterprise that does digital marketing, multi-channel retailing for some of the big brands such as Toys R Us, Sports Authority, a lot of common brands that you might be aware of are running within our platform on eBay Enterprise-enabled platform. And then there's all the adjacencies. Now there's about 50 of them. We just bought Paydiant. They're coming in all the time. They expect a certain level of experience that they're used to working with public clouds, working within colos. They need to have that seamless experience, so we need to be able to offer a very competitive storage and compute platform for them to build on, to encourage them to come on. So looking at the 2018 vision, looking 3 years out, these are the key areas that we see as where we want to pay attention. The first is we call flash everywhere. Now, it doesn't mean that we're buying flash, but we look at every area that we're buying storage and we say, well, we like the TCO characteristics of flash. What is that point where it makes sense? What are the cost points, the inflection points where it makes sense to put flash in that environment? And then we work with suppliers, and this would be areas like big data where it hasn't traditionally been in, where we can build those products and those technologies to actually get and realize those TCO and those other benefits besides performance with flash. Multiple flash tiers. Yes?
Just to make sure I'm on the check mark here. We're talking about flash storage as compared to flash animation.
Yes. Yes. Yes, flash storage, NAND, essentially. So multiple flash tiers, or NAND. We have performance NAND today, but we're also working on what we call big data flash or big data NAND, which is where we made some compromises in performance to give back on price. You're also going to see more processing capabilities being closer to the media. Maybe some ARM processors right next to the media doing things like basic storage capabilities like encryption or compression, but also being able to run maybe software really near to the storage, things like an object storage and OSD near the device and serving object storage directly. So storage class or storage class memory class storage, depending on, it's really about universal storage or the blurring of the lines between memory and non-volatile storage. There are technologies that we're interested in, that we're keeping an eye on, that we think that could have some potential here, and we'll talk about some of that. So storage densities hitting a petabyte in a rack unit. A typical rack would be about 42, 48 rack units, or that'd be about 50, or there's 50 rack units as well that we have. That would be about 50 petabytes in a single rack. The technologies that'll help us get there are going to be things like 3D NAND or some of these storage class memories. So the goal there is as we shrink down, we get some cost benefits with storage, and as well as potentially these technologies will give us mobile devices that will be in the terabyte range, right? So that would be nice. So storage networking, moving to Ethernet. Networking is a big part of storage. So we're interested in seeing how we can leverage Ethernet and move away from some of our fiber channel or InfiniBand network technologies. So we're looking at the roadmap of Ethernet. We're seeing that there will be some convergence as far as getting some of the reliability from the buffer-to-buffer credit and fiber channel to potentially priority flow control within Ethernet. And on the InfiniBand side, getting some of the InfiniBand protocols like RDMA or SRP into Ethernet with technologies like RDMA over Ethernet or RoCE, which is RDMA over converged Ethernet. Yes?
Since you brought up encryption, I presume eBay has had experience with this in terms of some of your users losing keys and stuff like that. Are you guys planning on bringing back key escrow on your storage?
No plans at this moment, although that might be interesting. Yeah, that hasn't been a focus of ours. Yeah. So now for having these capabilities in Ethernet, it does reduce. We have done some testing with RDMA over Ethernet. We have gotten very good latencies down in the 20 microsecond range. This is really important for the disaggregation of storage in the future, the separation of compute from storage, which allows us to do more interesting things with cloud and big data, getting big data on the cloud. Yes?
So you have technology like iSCSI and FCOE today. What's special in 2018 that you would see the convergence?
So FCOE, so fiber channel over, so that's not really, we're looking to simplify here. So we're looking to just really get the latencies down. And we've seen with RDMA that the latencies are better. We haven't done testing with FCOE, but it's not really, the trends aren't really going with FCOE today. All right. So iSCSI over RDMA, right? So that is something that iSCSI is in line with what we're doing. So exabytes of analytics. So our analytics clusters are big. When we talk about the data explosion, it's really about cold data. I mean, we look at the transactional core of what we do. That's not really growing nearly as fast as our analytics data. So I mean, it's growing maybe 20% year over year, whereas analytics is growing much faster than that. So we have all this big data is just surrounding and analyzing this core of transactional data that's producing it, right? So what can we use as far as storage technologies to help us reduce this big data sprawl that we're seeing in our data centers, right? So densities is definitely going to be one of those, pushing for density and storage is going to be one of those areas that we look at. And then, of course, hyperscale open source clouds. OpenStack, of course, we're very much involved with. But how does storage play in these environments? For myself, when we are talking to or looking at any product, we require that they have Cinder drivers. That's just a minimum to come into the environment. We kind of think of Cinder as a kind of open API that's common for all storage platforms. So it's been a very good development for us. Because before it was like every vendor had their own API. So looking at some of the historical trends, which can shed some insight on what kind of things happen to really change the market and might open the door for new memory technologies. So this is some data that's tracked on capital costs by John McCallum, and he goes back all the way to the 50s, but to focus on what we have here in the last 20 years, there's a bunch of trends here, a bunch of bumps. There's an earthquake here that happened in Taiwan. Over here in more recent history, in 2011, you see a bump in disk drive prices. That was caused by the massive floods in Thailand. That had a much more impactful situation on the market when that happened. But one of the interesting things, so the top line here is DIMMs. The bottom X's here, those are hard drives, and these lines here, these dashes are NAND, flash memory. And then down here you see SSDs really coming in, but they just fall in line with flash pricing. So does anybody know what happened here that really started to have flash pull away or NAND pull away from from DIMMs as far as pricing. There was an event that happened. I don't know if anybody. Yeah, close, but it was actually Nano. It wasn't Apple product, but that was about the time, 2005, 2006, that the Nano came out, and that's where it started to really take off. And there was iPods earlier, but it was really at that point where the market demand and the commitment by Apple to put in CMOS-based flash into their devices and the popularity of those devices that created the demand and that caused fabs to be, the ROI was there to invest in fabs to create more and more of this for the mobile market. So that's really what it's going to take if there's a new technology out there. We're going to have to get to a point where existing technologies are not really meeting the needs, and then a market phenomenon also needs to happen where there's an absolute need to shift to a new memory technology. They're not really frequently coming in. You can see, I mean, hard drives have been there forever. DRAM just came in there, and then flash really started breaking out. But it's not very common. It's not very easy for a new memory storage system to break into the market. So this is future, looking at the future, and this is from Wikibon estimations. And they're predicting that the green line up here is flash. The red line is hard drives, and then tape, which I'm not as interested in. But right, these top two lines here, you're seeing a convergence on price near in the 2020s, early 2020s. And flash has been depreciating 30%, and drives have been depreciating about 17%. However, for me, I buy mostly flash today, and given this CapEx gap that's in between flash and disk today, there are other interesting characteristics of solid state that we've been successfully able to convince the company that are worth looking into or thinking that are important to make it worth that jump to bridge that CapEx gap, which I call it, or at least narrow it. So, data center efficiency. Yes?
Sorry, would you mind backing up on the slide? The red and the blue lines have a curious quality of being parallel for 2 years and then dipping together and then being flat again and then dipping and then being flat again and then dipping and then being flat. Is there some inherent reason why the progress is made in both industries at 2-year intervals?
Yeah, actually, this is Wikibon's projections. I'm not exactly sure why or how they came to the flatter lines for those technologies. I think they're just not evolving as quickly. It's getting more difficult with drives to advance them to the next level.
The shape's almost identical, even though they're
Yeah.
separate technologies.
No, I can't explain why that is. Yes, in the back.
This is taking into account the advances in both magnetic recording and flash and SCMs.
Yeah. Those are so more like optical or more optical type or SCM. You're talking. This is not talking SCM. I mean, there's not a major market right now, but I'll talk some about that as well. Those are the technologies that are waiting for NAND to hit the wall, and they're just kind of, I call them in the on-deck circle, just kind of waiting for their chance. And something like maybe an Apple kind of making a commitment to one of those technologies, or a big buyer. Apple's one of the biggest buyers right now. Well, is really what it's going to take to create the market. So data center efficiency is something we care about. Operational costs matter, not just CapEx. I think too often when buyers are looking at storage technologies, they are looking at just the CapEx cost. But you do have to care about this stuff as well. This is power. This is carbon footprint. These are things that we measure ourselves by our KPIs. These are some of the measurements we take. This is actually one of our data centers. It runs off of fuel cell technology for the primary power source. So we try to do what we can to have a green data center. And when you dig down into these metrics, you start looking at, well, what's going into these metrics, and a big piece of that is the storage technology. And so if Flash has 30 to 60% more efficiency and power, that's something that comes into the equation for our decision and narrows that CapEx gap. And also it can depend on where you're deploying your data centers. Now for a data center deployment, you have to have a combination of good internet connectivity, as well as you have to have good power reliability. So typically these are the areas where a lot of data centers are deployed. If you're deploying in Japan, the cost is very expensive. It's gonna definitely factor into your equation more when you're deciding to buy Flash or not. Whereas if you're buying in the Western U.S. where power is relatively cheap, it's probably the only area in the world where power is somewhat stable. It's not as much, but it's still important. So looking at that capital cost model, when you look at Flash and hard drives, it doesn't really make sense just looking at capital costs. That's the cost of the networking and the actual cost of the devices. But when you look at the general TCO, then you look at the power. You look at also a big factor is AFR, the failure rate, is very critical in our calculations as well. We do find in our experience, we've been running a lot of Flash for several years. The failure rates of Flash have been much lower than spinning media. And that, you start thinking about things like, well, a lot of my activity in my data center is going into replacing drives, and I can be closer to a hands-free data center, if I deploy more Flash in there. So when you look at that, the operational costs, it really starts to look more equivalent in cost. And then when you factor in, of course, the IOPS, or how you're using it, how you're using Flash, then it can be even more compelling to the point where you may have to buy a lot more shelves of hard drives in order to make up what you get for Flash. So we see about 0.2 AFR, so annual failure rate with Flash, and I think it's about 1.2 for the spinning media today. But there are some other factors. We haven't been running it as long, so we don't really know exactly how it's going to fail at the end of its life. However, one thing that's unique about Flash is we can actually tell when it's going to die. We can predict a little easier because we can see how many drive writes have been going on, and we know what it's rated for, right? So that's nice. It's a little more predictable in that way. 0.2, and I believe it was a 0.12. Yeah, it might have been high on the drives, but yeah, percent per year. Yeah. So looking at the different kinds of Flash, we have this is a little illustration about how the wear happens, and the difficulty, the challenge with Flash going forward is really about endurance. Endurance is the main issue. When we look at SLC, which is a single bit per cell, MLC dual, and TLC, which is 3 bits, if you look at it in a drinking contest or a drinking game, you say to a bartender, someone says to a bartender, hey, I want 2 bits in my MLC, and they fill it up. And if you guess right, when you look at it and you guess right, then you take the shot. If you and you keep doing that, and as soon as you can't read it anymore, it starts. The lines start to blur, both your vision as well as they get worn, and then eventually you're not able to read as accurately anymore. So with SLC, it's a lot easier to tell whether it's full or not. But as you get down to TLC, it gets more difficult more quickly, right? So this is some of the challenge there. In TLC, while it gives you the density, you're losing out on endurance, and it's a balance. Disclaimer there. I'm not recommending you play this game. So a big problem for Flash in the market is we treat flash like it's disk too often. If flash is flash, it's not disk. It's playing on a field that's really built with rules around disk and optimizations for disk. Some of those optimizations, the areas that we can improve on are, kernels and file systems, and they're all expecting disk, and they all treat the media, the storage media, like it's a disk. So, for instance, when we looked at, okay, well, can we, if we have flash that's fast enough, like if we have NVMe, which is a very fast protocol for drives, replacing SAS potentially. And we've seen latencies in the 20 microseconds range. If we have a very fast storage device and we wanted to use it to extend memory relatively cheaply, and maybe get more hypervisors or more VMs onto a hypervisor, could we do that? Well, the challenge is the kernels treat when they page out large pages sequentially, and they're not really treating it in a more optimal way for flash, right? So that's one challenge. And then the other is with applications. So we threw flash into one of our search applications. We found that we were getting better performance, but we weren't getting what we expect for twice the cost. So when we looked at it, we found out they were buffering all their writes and then doing a single sequential stream out to the disk, or what they thought was disk. And that wasn't really, if it did a little more random parallelization, which would be a lot faster, it would have been much better and taken advantage of the flash. Other areas are with controllers. Flash does not fail the same way as disks, yet we treat it like that. We treat it like it's failing disk. We have enough level of provisioning. When it hits to that level, we fail the whole thing. Now, flash, we've done some testing, and we've said, okay, take some random flash. It has a certain amount of program erase cycles, which is those pores in the drink, and just run it until it fails, right? And what we found is that the flash, if something was rated for, say, X program erase cycles, we could actually run it 40X, and we'd still have about 70% of the flash that was usable. And so we're throwing that away, at 40th, at the point where we did, so where we could still use it. It seems like a waste. Maybe we should treat it more like it's like a gas tank, like it's reducing over time, instead of just throwing out so much good flash. So the other areas, in other areas, if we're running TLC, and it's starting to get to the point where it's getting hard to read, we could do some more creative things about, well, we can re-represent the flash, make it, maybe we make it look like MLC, and we can read that a little bit better, right? And then when that gets bad, we can change it into SLC, and we can just reprogram the flash to have a little more endurance and keep it a lot longer. So those are some things I'd like to see as well. And then, of course, software-defined storage. A lot of it out there, especially the open source stuff, is not optimized for flash at all. We've done testing. Oh, sorry, in the back. Yeah, first.
Wondering, when you talk about wearing out flash, do you think in normal use that it would actually wear out before it's obsolete? That is, you'd want to replace it with something higher density?
Yes, that is. It depends, right? If that is definitely something. Depending on how long you can make it last, right? But yeah, it's just having that flexibility, I think, is useful. So if you made this investment, and you can move your TLC deployment into an SLC deployment where you need more performance, you now have that option, right? Instead of just throwing it away right now. But yeah, there could be newer technologies that you might want to move to.
Do you actually throw it away, or do you just sell it onto a secondary market?
When a flash device fails, it's replaced. Yeah.
What's replaced from your perspective?
Yeah, no, as far as what the vendors do, yeah, I don't know. They could be repackaging it and turning it into thumb drives or something. But yeah, it's as far as is how the market treats it today, how a lot of the flash devices and arrays treat it today is they just throw it away. Yes?
But back to the question of when you get rid of it, you don't want to be doubling your data centers every year.
Yes.
So footprint matters. Power isn't the only thing, footprint matters too.
Mm-hmm.
And so if you're dropping from TLC to SLC, it was already a low density device because it's old, and now it's even worse.
Yeah.
So it might not matter that it's still got good bits because you can't afford the space.
Yeah, that's true. But if I'm buying SLC, I no longer need to because I have a supply coming in, right, for my more high performance workloads. And we do characterize, and we do have we call it IOP per terabyte measurement that we have for all of our workloads. So I could be buying for the TLC use cases, and then as it cycles out, I could move that into the SLC environments or MLC. So I'm not buying SLC anymore.
Do your applications care about the variability from the things that are hiding from you, like what the flash controller is doing and the garbage collection that could happen at any time?
So the applications.
Do they worry about performance variability? Do they care about the latencies and so on?
Yeah, I mean they may, and we'll have to put it on the appropriate location if they are that sensitive. I mean, we do have some very sensitive applications, especially in the fraud detection space, that are really the lower the latency, the better. But we'll just make sure we're putting it on the right media, right? But there's a lot. I mean, talking about like big data, there's a lot more use cases that are not as latency sensitive, right? So big data flash. So we heard a lot of performance, right? And so say, okay, we're sold on the performance, but we like the other aspects of flash. We like the power. We like so we went back to the vendors and we gave them all the requirements. We said, look, we give back on performance. Give me back something on cost, right? So that way I can deploy more flash in more areas. Right, so we said, basically just merely beat the drives, beat the enterprise drive, the nearline enterprise drives that I'm using in my Hadoop environments. Don't blow them away. So we figured out that a 30 cent per gigabyte target is about the time where it really the inflection point where it really makes sense to replace all the nearline drives. So but initially we said, okay, we don't really need that at first, but that's the roadmap we want to get to is 30 cents per gig for flash. So we've been working with many of the manufacturers to give us some of that. So for instance, in a software-defined, this could be Hadoop, a software-defined storage situation, could be Hadoop, could be Ceph. To typically do a 3 replica model. And if you're paying for nearline drives, enterprise drives, about 25 cents per gig, this is all just sample costs, not our actual ones. You're paying about 75 cents. But say you introduce a flash replica, and then you start moving, you can move your workloads there, potentially get better capabilities, and now you can move your other replicas to a lower tier or a consumer grade drive, which is much, much cheaper. So now you're getting better performance characteristics, and you're able to maintain the cost structure. So that's something we're actively doing today in our software-defined storage areas.
Question: what is the current pricing per gigabit?
Current for which kind of?
Your target is 30 cents per gigabit, right?
Yes. So what are we at right now?
Yeah.
So I can say there's some products that have just been recently announced. One of them was the SanDisk InfiniFlash. I don't know if you heard, it was released a couple months ago. That was one that that we were interested in. I believe they announced it at about $1 a gig as the public price. So that's what we would term as a big data flash, right? That's what we would define it.
This transition, are you assuming that the rate of failure, the change in the rate of failure model changes is masked by the software that's running on this big data stack?
Yeah, it would be with, they typically do the software stack, software layer. Yeah, there's none at the hardware level. Yeah, I'd like to actually have the ability to even just remove replicas. We just have more flexibility with the software storage models to control the costs a lot better, especially as data ages. We want to make sure we can put like maybe 2 copies on cold storage and keep one that's active for the occasional person who needs to do a bug fix. So, and the other trend we're seeing is the commoditization of flash arrays. There's a kind of a do-it-yourself, build your own flash arrays, and there's a lot of technologies out there. There's very dense media, 4 terabyte, 2.5-inch drives. You have this other one is an 8 terabyte custom form factor. And when you start getting away, again, going back to where we treat flash as disk, well, we're still using disk form factors. Well, we're starting to get away from that too. We can get a lot more density if we do custom form factors with flash. And then you have very dense storage enclosures that you can build. Like this one on the bottom left here is a 62.5-inch drive 2U enclosure. There's actually even denser ones coming out. And the other one is a JBOF, this is the InfiniFlash product, that is 512 terabytes in 3U, which is probably one of the densest flash products out there. And these have a roadmap. They're going to go even denser. With as flash advances, as the media gets denser, they're going to go to a petabyte in 3U. So that density has a lot of implications for just saving on data center space, especially if the cost is the right place. And then software-defined storage, of course, sitting on top of it. And when I talk about software-defined storage, I really define it as I control the hardware relationship with my vendor, and I'm only really buying software anymore from the storage vendors. And many of them are going in that direction. So just today, we have arrays that are about 180 terabytes in a rack unit, as normalized in a rack unit.
So you mentioned form factor. How about the interconnect? Are you seeing more PCIe versus traditional SATA connect?
Well, we're starting to see more. I'm more hopeful for NVMe. There's a premium right now on it, but I think as more next half of the year, we're going to see more competitors. Right now, it's Intel, and there are products that do have NVMe drives in them. I think some of the actually there's a lot of Dell and Oracle have some, but once the new competitors get in, there are probably like 4 or 5 of them in the next half of the year. I think you're really going to start to see competing with SAS and potentially, because there's no real, as far as cost of manufacturing, it's actually it should be better, and you're removing that SAS layer, which is introducing a lot of latency. iSCSI or
HP was kind of promoting SCSI over PCIe, but I guess you're more in.
Well, there's NVMe over Ethernet as well,
yes.
which I'm seeing some of too.
Okay.
But I think NVMe is really designed for flash in mind. So I think we're going to move away from, well, maybe not move away, but they might get supplanted with some of these other older protocols which were designed for more disk. But I think NVMe is the future here. So storage class memory. So this, as I said, this is kind of the on-deck circle waiting for their opportunity. They all have various characteristics. So Spintronics or STT RAM. This is looking at the spin of electrons and the polarity and determining the bit of data from that and controlling it through magnetic field. It's been around for some time. Not a lot of practical applications. And then there you have phase change memory. So this is where you have a a substance, or it's a glass-like substance that is amorphous, and you fit with through thermal reaction, you can change it from crystalline to non-crystalline, and that represents your bit, right? So it has some issues around power. It takes a lot of heat since you're basing it on thermal activity. So that's been also in research for a long time, but it's still I think it's not really going to be something that we're going to see in the near future as far as products. The one I have the most hope for is the one on the left here, the resistive RAM, and there's various forms of it, but essentially it's a filament which which enables a current between two cells, and whether it's on or off, or the resistance that's measured between it, is really what determines your bit. So you have companies like HP has memristors, Nantero's carbon nanotube RAM, and then there's a crossbar. I think this technology actually is, we'll start to see some products in the next a year or two. And this has a lot of promise because it doesn't have the endurance issues that Flash does. But it doesn't have the mind share right now that Flash has as well. So they're going to, the manufacturers, the fabs are really going to push NAND as far as they can. And right now, it looks like as long as there's a roadmap there, and with 3D NAND, where if you take 3D NAND is where if you take if you imagine the cells in TLC, MLC, in planar NAND, so it's in one dimension, and a single SLC would be like one person living in a house, MLC would be two, and then TLC would be three. Well, now you're making a skyscraper, right? You're building up from that. And so there are products out there, or chips out there that are at 3-layer right now, and potentially 4-layer coming up. Well, those will get us to, those will 3x or 4x the density that we're getting out of those chips, and potentially get us to start talking about terabyte phones. So with that, I'll hand it over to Farid. We'll talk about some of the applications that we're in.
Yeah, thank you. So I'm Farid Yavari, one of the architects at storage architects at eBay. And I'm just going to take a step back, talk a little bit about the company and the road we've been on, starting in 2009 and up to today. And then we're going to go, as part of the presentation, we're going to go into our some of the data center designs, and also we're going to also talk about some of the solutions and challenges that we see in our environment, especially the newer trends that we are seeing in our data centers and the type of problems that we're trying to solve. So back in 2009, I think so this is a slide that I got from our CEO, and he really likes to talk about the journey that we are on, and the journey started back in 2009. So coming forward, with the introduction of the mobile, technology, really, the whole e-commerce and commerce kind of blurred together, and we are talking about commerce now, and it includes everything from brick and mortar all the way to online shopping. So imagine if you walk in a shop and then you're in the market to purchase a pair of shoes or maybe a jacket. You can walk into a shop, you look at the merchandise, you try it on, and right then and there you can scan the barcode on your phone and try to see if you can get a better deal online. So you see how the whole commerce is changing, and how there are different dynamics. So as far as the data center is concerned, it has to be able to support a different type of workload, different type of environment, and different types of use cases. So it's more of a omni-channel type of environment right now that we're dealing with. And it also, from the business perspective, it actually puts a lot of different perspectives into how branding is done, how companies are doing the brands on their merchandise, and the same way we have a social networking type of site, we're going to have a social business where the information is flowing and all the brands are kind of, they're coming together, and also, what the user actually provides is total access to the user profile and the purchase behaviors. And also, what happens is, with the mobile technology, as you're walking through a mall, for example, the different merchants can actually send you different kinds of offers depending on your localization, where you are, and also the analytics behind, what type of purchases you've been doing, and your user behavior and things like that. So the whole commerce landscape has changed, and as a result of that, the infrastructure that supports that landscape also needs to change. So there are a few data center trends that I like to talk about. So one of them is obviously, like Russ was mentioning, the explosive growth in storage. All this information that supports, the commerce, e-commerce, and the whole ecosystem is basically it's explosive growth in storage. So we need to be very uh, we have to actually come up with different type of technologies and get very creative when it comes to storage technologies, especially for big data analytics, and the whole aspect of object store with a disaggregation model, and the whole new the NoSQL trend, where you have different type of unstructured data that you need to deal with, and the technologies behind that. So one of the initiatives that we're actually driving as part of this explosive growth in storage, one of the initiatives is disaggregation of storage and compute. Because as you have storage and compute in one box, every time you add storage, you automatically add compute, and vice versa. So in some environments, you're very storage bound, and you have to keep adding storage, but by default, you're buying CPU as well. Or if you have a CPU bound environment, you don't want to keep adding storage to the environment. So the disaggregation is there, and the disaggregation is something that needs to be dealt with. And they need to be scaled and refreshed independently. Uh, as part of that, once you disaggregate your storage, a lot of load goes on the network. As the storage and the network, as the storage and the compute are in the same box, all the traffic, obviously flows over the bus, either the SAS bus or the PCI bus. But as you disaggregate these, then you have to rethink how you do the networking, and how much cost it actually adds to the whole infrastructure. And scale-out solutions, obviously, at scale, are always a TCO conversation. So that comes in mind, every time we talk about that. Give you an idea of our environment. So, it grows 20% year over year, and for the OLTP environment, and I'm going to get into the details of how our environments look like, different silos that we have. So in our OLTP environment, we have about 20% growth, but we get a 300% growth in our analytics environment. And we need to deal with that, as part of the infrastructure team. So this is the size of our managed infrastructure. So we have a SAN environment based on Fiber Channel, handles our OLTP transactional environment. It's about 80 petabytes of that. We have a huge 6 petabyte NAS implementation, and object store, about 30 petabytes. And analytic environment, we're anticipating close to 1 exabyte by 2016. So that's the environment that we really have to get our arms around. As far as the size, again, 130 SAN, NAS, flash storage arrays in 3 major data centers. Our data centers, one of the newer ones is in Salt Lake City, and it's state of the art at this point. But like we're mentioning, we have some density issues there. We have power issues there that we need to address. And we have about 1.4 million peak hour IOPS just in our SAN environment to handle the load. And we have obviously thousands and thousands of servers. So as far as our environment, we have an OLTP environment, online transactions. It's primarily Fiber Channel and Oracle based, and it's one of our legacy environments right now. One of the environments that changes very little, but it's the bread and butter of the company. Primarily, the growth is kind of low in that environment. Scale is in petabytes. And protocols we use there, fiber channel, NFS, and some very little iSCSI in that environment. The other environment we have is the NoSQL environment where we actually run Mongo, Cassandra, Couchbase, those type of technologies, and it's usually the back end to our mobile apps. And there, right now we have a DAS model there, but like I mentioned, we want to get into a disaggregated model where we have separate racks of storage, separate racks of CPU or compute, and then we can scale them independently. And the growth there is about a medium growth, and it's either a DAS, and it's some areas we have iSCSI, and we're trying to get to more iSCSI in that environment. And we are trying to get to a Cinder controlled environment. We have one vendor, one vendor in that environment that's a disaggregated model, and we use their management software at this point, but we would like to eventually go to Cinder. Big data is the next environment we have. Big data analytics, primarily Hadoop, HDFS in that environment. It's a local DAS model, and over there also we are investigating some disaggregation of storage. Especially in that environment, most of it is storage bound. We constantly run out of storage. Some of our jobs actually fail because we run out of temp storage in those environments. So we have to restart our map reduce jobs and stuff. So as part of that, we want to be disaggregated. We want to be able to allocate more storage where we need to. It's in hundreds of petabytes. The growth is very high. And we have a DAS model going to iSCSI, and we are considering object in that store, in that environment, object store. Swift, Ceph, Cinder, those are the management. And also the private cloud that we talked about. So OpenStack KVM-based private cloud, and tens of petabytes in size, so on and so forth. But if you look at this landscape, we can actually divide it into two separate environments. So one is our legacy environment, is SAN, storage appliances, and the other one is actually the rest of our environment. So most of the changes that we have at eBay and the new technologies, they get introduced on the right-hand side of the slide because it's a lower risk environment, and it's not a legacy environment. It doesn't have as much baggage, and we can introduce change in that environment a lot easier, and we can test out whatever concepts we have in mind easier in this environment. So we have some key initiatives. The key initiatives that we have in these environments, basically, separation of storage and compute, especially for Hadoop. Yes?
Separation of storage and compute. I mean, I'm a little puzzled here because it's the way I'm thinking of it, that you have a storage node. If you're running Cassandra or any of those things, you need CPU there, and the more you load it, the more CPU you need. And if you're going over the network, typically you even need more CPUs. So, if you say, well, I'll just combine these two and make them the same, you'd say, well, maybe there's some differential in the amount of CPU you put on there. I mean, even in memory, you'd say on a storage node, I want lots of caching, so DRAM caching. So, have you actually done a profile where you say, my ideal storage node is this amount of compute, this amount of DRAM and that storage, and my ideal, storage node is some less, and then of course is the cost of networking, as you mentioned, yes, where you're putting, and usually networking, as you know, can be expensive stuff. So you're thinking the total cost of ownership, does it make sense to just make all the nodes the same and forget this disaggregation?
Yeah, when we talk to our application owners, what they say is that if for different type of use cases, they need a different disk to memory ratio. And they want a centralized location where they can carve out whatever amount of storage they need and allocate it to these use cases. Basically, the conversation there is flexibility. And, uh, and you're absolutely right. The cost of the network in a disaggregated environment is about 25% of the entire of the entire rack. So each rack, if rack costs $100, there's a $20 to $25 cost for the network. Yes, so it doesn't matter, but if you have it out on a separate rack, you have this pool of storage that you can actually carve out as you desire, and then you can put as. So that's another, yeah, exactly. That's another model that you can follow. But then again, you're confined to how much storage you can fit in a chassis if you have the storage and the network, the storage and the CPU together. And if you run out of CPU, you have to buy another chassis where it also comes with this with the other component that you don't necessarily need to add. So
compare where you say it would cost, if I just say it's all going to be the same node or same design, and just cookie cutter it, is it,
Actually,
what's the extra cost?
Part of that is, so another goal that hasn't really been stated is the narrowing of the number of SKUs that we have. And so when we look at what we're doing in big data, we really have custom SKUs, or we have SKUs that are built for that are storage heavy. Being able to split out some of that storage, some of it can be done through tiering, but being able to move that storage out and have my workload actually run on a common SKU actually simplifies things, because I can now have my big data workloads running alongside on the same SKUs as my edge tier, as my NoSQL, and I can now move workloads around a lot more easily. So having the ability to push all that intermixed cold data out of the big data environments and have a cloud or have a very elastic, really compute focused with very narrow, with a limited SKU, with a single SKU, is another thing we're trying to achieve there.
Okay, so if you do workload management though, and run a high compute low storage and a low compute high storage on the same physical box, then you can get to the single SKU in the same way.
Yeah.
But then people they don't own their box, but you don't let them own their box anyway.
Right. No, there's no. They're all treated like cattle. They're not pets, right? So, yeah.
So people don't own boxes anyway. So back to this point of then you get the balancing. You solve that problem by workload management.
Yes.
right. And also the flexibility to actually reallocate your CPU compute resources is another aspect of this whole thing. So you can have a rack of compute that you can allocate it to your Hadoop analytics environment and run the Hadoop intensive jobs. And if the storage is disaggregated from that environment, then you can actually, reallocate that rack of compute to your front end. If you have a high season, for example, in e-commerce, or you can actually move your compute resources around without having to move your storage resources around. It gives you flexibility. It gives you a way of reallocating your resources or reusing your resources in a way. So as far as the key initiatives, again, the disaggregation is one big initiative we have. Software-defined storage. So we have the ability right now to actually contract manufacture some of our storage boxes. We also interact with a lot of storage vendors out there, and we try to allocate time to influence their roadmaps and somehow ask for the type of products that we would need to consume in the future. And so when we get these solutions in, it's just a box it's just a storage box. So we need some kind of a software to actually run on top of these environments, whether it's a contract manufactured environment or any other environment. Then we need some kind of like a management layer of software on top of these boxes. And with software-defined storage, we can actually do these type of stuff. And software-defined networking obviously is another aspect of it, because for this whole disaggregation to come in play, we need both SDN and software-defined solutions. And eventually the goal is to actually move to a cloud OLA-based, SLA-based type of as-a-service environment. So one of the initiatives that's on the for the DBAs, for example, right now for the database team, is to provide database as a service in our private cloud. Infrastructure as a service, platform as a service, software as a service, and eventually, database as a service. And it all needs to be self-managed. That's where we get to complete flexibility in our environment. As part of this, then, once you become disaggregated in your environment, the next question is the data tiering. You don't want to keep all your data in one tier, especially for your Hadoop analytics environment where you have maybe 5 to 10% of your data active and hot. And as time goes on, it becomes warm, and then you gotta move it to archive and eventually cold. Keeping the data in one tier becomes very expensive at scale. So, the next obvious step would be to do a data tiering strategy. And, we are actually working with some software startups, software companies to provide data tiering for our Hadoop analytics environment based on the information that's there, and, heat maps and policy driven, basically. And again, it ties into our TCO models and all that stuff. So, the model that we have right now is what we used to have is basically individual servers with DAS, so direct attached storage in each server. And that was the model that worked for us before we scaled to this size. And now we're seeing that keeping all the data on the same layer is not economical. So we have actually, starting this year, we moved to this model where we keep our hot data inside the server. And then we try to actually offload some of that data where we think we don't need anymore. At that point in time, we offload it to a lower cost platform in the infrastructure. And that has saved us a lot of money. The TCO that they ran is around $20 to $30 million only by doing that. We are actually shipping off some of the data into our cold, so to speak, environment. But the goal is to actually get here where we have a really thin, hot layer of data inside our servers. And then, we have a warm layer, and we have a very cold layer of data, which is usually over a year old, but we still need to keep it around. With e-commerce, you need to be able to go back year over year. So, for example, this year, holiday season, we need to be able to see what last year's holiday season numbers and trends were or the year before. So every year we need to actually go back and look at the data that we haven't probably touched in about a year. So the data needs to stay around, but not necessarily on the same tier. So what we see basically is a triangle like this as far as what storage technologies are concerned. Yes?
The illustration suggests that the TCO may be the same, or maybe there's not much difference because you seem to be moving costs around where you'll need a more beefier and a fatter network in order to accommodate for the disaggregation that you're doing. So do you have any sense of how much it affects the TCO by moving on to this model?
So the fact that we are actually keeping the hot layer inside the server we are confining the network traffic. We don't even go over the network that much. We just access the data that we need inside the server still. And the data that we infrequently access actually gets tiered off. So the network overhead there is not as much as if you had a total disaggregated model.
But if you have multiple applications running on each server, it will be very hard to come up with the right heuristics for what's hot and what's cold.
Yes, so for different use cases, it's different. This model we are actually implementing only for our Hadoop analytics environment at this point. And there we have a very, it's a standard type of pattern that we follow.
So there's policies you could put in place. And they're general, right? So, data is more active when it's first ingested into the cluster. So we just ingest it onto the hot tier, process it, keep it there for maybe a month. But when you look at the total size of the cluster, keep that month's worth of data is really not that big. So it's not a heavy investment. It might be a couple racks, right? So, and then what happens is that area is not growing as fast. That active data set is not growing as fast as that cold data set. But now you're investing in it. It actually costs less to expand that cold data set. So
right.
That's where we start gaining the TCO really starts making sense, and we save a lot of money because all I'm buying is cold.
Yeah, the data management over time becomes the cold data management. How you manage the data that you need to keep around, and it's cold, but still needs to reside somewhere. Yes.
Transparent, or what's the API to the data tiering? Like in your case, if I'm going to run some application that wants to reanalyze what last holiday season is, does that application or me have to say, haul in this stuff from cold storage, or do I just try to access it and it just
No, you try to access your data, and the software layer, the tiering software that I was talking about, correct. It actually is intelligent enough to bring back the stuff that gets frequent access after a certain point of time. So we are looking at some intelligent software based on heat maps and based on policies that we set to actually do the data movement between these tiers. So the application doesn't have to be aware of what's going on underneath.
I'm going to look at last holiday season, I drag in all this stuff, and nobody's going to look at it again for a long time. So you'd have to distinguish between something that's archival that just got sniffed once a year from things that are brought in that somebody discovered is very interesting.
So that's where the policy comes in. The way you set the policies. You can say if a piece of data is accessed, more than 5 times in a day, then bring it back. Or if it's accessed once, I want it back immediately. It depends on your use case and the type of policy you set. But if the policy is to actually, as soon as you access any piece of data that's been aged off, you want to bring it back all the way, then of course there is an overhead and premium to pay. That's for sure.
Before you start accessing the data, in the case of the holiday data, you want to spend November getting the data for October, or October getting the data for November.
Yeah, that would be another policy to set probably, yes. So that piece of software that actually does the tiering, it can get very sophisticated, depending on what level of functionality and capabilities you want it to have.
But the application doesn't see that.
No, the application just requests the data. And again, like I said, this is just for our Hadoop Analytics HDFS environment. So as the gentleman was saying, if you have different types of applications with different requirements and different SLAs, that it becomes even more problematic at that point. But you're correct. Yeah, the application is not.
That describes how your data is going to be laid out and accessed, and the application doesn't know anything about that.
Yes, yeah. So the application just allocates the data. If it does replications, it does the replication natively as it always does. But underneath, everything is managed. The whole idea here is to move the data to the right tier and pay the right amount of cost for each bit that you save. So, the whole stack as far as, very expensive storage, main memory all the way to DDRs and then to flash and all the way down to SAS and SATA and eventually tape uh, and so on, obviously cost per IOP and cost per gigabit or gigabyte that changes a lot based on that. Now there is a shifting paradigm in storage, and different types of technologies that we are actually looking at, and different types of cadences going forward. So for hard disk and SSD, flash, and then storage class memory, these are the targets, and these are the trends that we see over the next 2 or 3 years. And the source of this information is the market trends and also some of the roadmap discussions we have with our partners and our vendors and the companies that we interact with. So, as far as the HDDs are concerned, within a year, within 2 years, we are expecting to see 10 terabytes for HDDs. A solid state, in a couple of years, we are expecting to see 24 terabyte. Actually, we have some samples right now, 4 terabyte SSDs. We are running the 2 terabyte Samsung in some of our solutions. And as far as the flash PCIe, NVMe is definitely something that we see a lot of traction in the industry. We see a lot of roadmap products that will be announced this year and next year, early part of next year, with PCIe and NVMe, both in small form factor and also card form factor in server. And those are the type of trends that we see in the industry. And then storage class memory, that's the carbon nanotube, resistive RAM, and all those types of different technologies. So as a conclusion, I have this slide, the changes and the challenges and the opportunities that we see in this whole storage environment. Storage is very, very interesting now. If you talked about storage maybe 10 years ago, you wouldn't see this many innovation, this much innovation and this much activity in this area. But right now, we have some challenges. We have some opportunities. On the right-hand side, you see, the near-term type of opportunities that we see, and at the bottom, the 5-year plus. So, stuff like, the paradigm shifts and, different types of media, the failure domains, one of the concerns is there as your storage racks get more dense, and you have a separation of storage and compute, as the rack goes down, or if you lose connectivity to that rack, you basically lose connectivity from all the servers that are pointing to it. And obviously, as these things become more and more dense, you have more CPU, more servers in front of, the storage racks, and then you have to deal with how do you manage the environment, how do you manage the risk, and that kind of stuff. And everything, again, it's a TCO conversation for us. We have to see every new technology we bring in, we have to actually see how it works in our TCO model. We have a very extensive, TCO modeling as far as, with everything built in. So it's the cost of ownership, cost of operation, CapEx, OpEx, cost of electricity, and, the facilities, everything else. So, and we have it down to, a sub-dollar as far as, how much each rack, each floor tile, and everything else costs for us. So it has to play. And, every solution that we look at and we propose, we have to actually justify that within our TCO models. So, and also number 5 there, the new medias on horizon. That's something we're very excited about, something that we have some traction with, some companies in the industry that, they're working hard Nantero, one of them, Crossbar, another one. These are these and HP. These are. We're really hopeful to see some products come out, and also very very interested in the 3D solutions, 3D NAND solutions, and so on and so forth. So, basically, these are the opportunities, and we are actually looking to see who can provide, or which companies, which solution providers can provide the type of functionality that we are asking for, and have the type of products out there that we can consume. So that's all I had. Any questions? Any concerns?
Yes. There's a fellow a few years back from Facebook who came here, and he was pushing this angle of wanting the manufacturers to drive down the cost of flash, and he wanted write once flash. And does this make any sense to you? Have you seen any traction in that direction of just really low-cost flash that you only really reliably write once?
We don't need, no, write once is not a use case for us, but a drive writes per day, a low drive writes per day is something that we are actually asking for. A lot of the vendors have very high endurances in their flash devices. And when we really look at our use cases, we don't really need 10 drive writes per day. We just need a good enough, but at a lower price. And that's what we need. But to basically write it once and never write again, we hardly have any use case for that. Yes.
So what's your experience in terms of just plain bugs in the firmware down there that you don't get a chance to see?
Yes.
Do these things fundamentally work? Or?
Yes, so the SSDs, they fundamentally work. They work differently with different manufacturers. So if we get 4 samples from 4 different companies, we see some kind of a difference as far as performance and the way they handle the I/O. So when we do the performance characterization, it's obvious that this vendor is better than the other vendor because it handles a lot better under certain circumstances. But we haven't had any major issues that the technology is not a viable technology. We haven't seen that at all. As a matter of fact, we have a huge deployment of flash in our environment. And aside from the regular issues that you would expect, we haven't seen anything unexpected.
Is there a layer of software between you and the real flash?
So, yes, so yeah, so you have the FTL, you have the drivers, you have the OS. And is that what you were asking? Or?
Yes.
Yes, yeah, definitely, yeah. Yeah, we are just the consumer of flash. So, we rely on all the layers to...
This mismatch between what flash does well and what you can ask it to do.
Yes, so we have a battery of tests and profiling tests that we run, and we just hammer the device and we keep stats, and depending on who's underneath, we kind of characterize that with the whole stack on top of it.
It's easy to punish it. The question is, how well can you exploit it?
We primarily use VD Bench as one of our test cases or tools. And with VD Bench, you can actually have different characteristics, so you can control the IOPS and the...
Have they assumed that it's a hard disk? Or have they assumed that you assume that it's a hard disk?
Well, it's not a hard disk, though.
I know.
Yes.
That's the problem.
So, no. So we actually characterize it as a flash device. Yes. We don't characterize it as a hard disk.